So this is a question sent by one of my students, and it reads like this: 1 kilogram and 2 kilogram, these are two blocks, are connected by an ideal spring having a spring constant, it's given. They rest on a smooth horizontal ground as shown. A rigid sphere rotating with angular speed 30 radian per second about a diameter perpendicular to the plane of the paper, having radius and mass, is falling from a height and collides with 1 kilogram block. So this is a sphere which is falling from some height and it's colliding with this block. The coefficient of restitution is given, coefficient of friction is given between the sphere and the block, and gravity is given, mass is given. Okay, and there are two parts: angular velocity of the sphere just after the impact and maximum elongation of the spring after the collision. Let's see how to solve this. Okay, so this is the sphere having a velocity equal to under root 2 gh. It is the velocity just before it collides with the block. And since in vertical direction block cannot move, so this sphere will strike the block and go back, and using the formula for E is velocity of separation over velocity of approach, we'll get velocity of separation equal to E times velocity of approach. So it will return back with a velocity equal to E times. And suppose in this direction, normal direction, there is an impulse of normal. It is denoted by IN. IN means normal into time of collision. And this IN will be equal to change in momentum. IN is upward, so we have taken upward as plus. Final momentum is positive because it is upward. Initial was negative because it was moving downwards. Okay, so this is the expression, and putting the values of M, H, E, etc., we get the value of IN as 15 Newton second. Okay. Now there is also friction between the block and the sphere, and suppose the impulse of friction is IF, and this is the situation. IF is the impulse. This IF will change the momentum of this sphere in this horizontal direction, and suppose it acquires a velocity v when this IF has applied to the sphere. This v will be IF over mass, because IF is impulse, that is change in momentum. So initially there was no momentum, so final momentum is m into v, so that is IF. So since m is given as 1 in this question, so that is simply equal to numerically IF. So the velocity it acquires is equal to the impulse of friction. And similarly, the action reaction of this IF will act on block, and since block also has the same mass, m equal to 1 kilogram, and therefore it will also acquire the same velocity as the velocity acquired by the sphere, but in opposite direction. Okay, so the condition for no slipping I am just finding, because friction will act till there is slipping, and when slipping ceases, friction will not act thereafter. So condition for no slipping. See, with respect to block, the sphere is moving with velocity 2v. So that 2v should be equal to r omega. So this is the condition for no slipping. Put the value of r as half meter given in the question. So that half transfers to the other side and omega becomes equal to 4v. So this is the condition for no slipping. Now, this friction, the impulse of friction, this is force of friction into time. If you multiply by radius, then it becomes torque into time, and torque into time is change in angular momentum. Now this IF will make a torque in anti-clockwise direction. In an anti-clockwise direction, I am taking clockwise as plus, suppose. So this is a negative torque, and this is equal to I. This is a moment of inertia, 2 by 5 mr square. I have put the values and solved it. 2 by 5 mr square. And this is omega final minus omega initial. Omega initial is given as 30 in the question. So what I've done, I've just put the value of IF. IF we have found as equal to V, and V is equal to omega by 4 from here. So I'm just replacing IF by omega by 4, so that the whole equation comes in omega, and we can solve for omega. So omega is coming out 40 by 3 radian per second. Now let's find the required IF. It should not be more than the available IF. So that check we should make. So if omega is 40 by 3, then V is omega by 4. So V will come out equal to 10 by 3, and IF is equal to V. So IF will come out 10 by 3. So this is the impulse of friction required for producing no slipping. Now, how much is IF available? What is the maximum value of IF? So that is mu times IN. So IN is 15, mu is given as 1 by 3. So that is available. So IF maximum is 5 and required is less than 5. So it's all okay. So this much of impulse of friction will be developed, and omega final will be 40 by 3. One thing I will like to add, this IF is impulse of kinetic friction. Here we are not saying that friction is less than mu n. Friction is always mu n. Only when IF is less than IF max, it implies that IF is developed for a smaller time. It is mu n, no doubt. Friction is always mu n because it is kinetic, and it will not develop for the full time of collision, and therefore IF is smaller than the maximum. Suppose full time of collision is t, then IF may develop for a smaller time, not for the full time, and for the rest of the time there will be no friction. So this is how IF and IF max, they are different. Okay. Now the next part of the question, now we have found the velocity of this block as 10 by 3. Now we have to find the maximum elongation of the spring. When maximum elongation occurs, velocity of both blocks will be same, and from momentum conservation, this V is 10 by 3, where conservation of momentum implies, so initially momentum is 1 into 10 by 3, mass is 1. Finally they will have common velocity, suppose V dash, and the total mass of system is 3. So this will give V dash. This is the common velocity of the blocks at that instant when the spring is stretched by its maximum. And then applying energy equation, we can find this x. So this x is the maximum elongation of the spring. Okay.